Okay, very quickly. Or first of all, I'll say f of x minus h is x minus h quantity squared. I think everybody pretty much on track with that. F of x plus k is f of x is just x squared plus k. You don't, k is not inside the parentheses there, doesn't replace anything. Okay. You don't have any replacement to make. You just write down what f of x is, which in this case is x squared, and then you add k. And then a f of x, that means a multiplied by f of x is a is 3 times x squared. Okay. Everybody okay with that? Good. I'll put the numbers in a minute. Let's see. If f of x equals 2 to the 1 over x, h equals 4, k equals -5, a equals 1/3, then f of, and I said x plus h, didn't I?
Yeah.
Well, if you did x plus h, that's fine. But I really should have said x minus h. I was careless. Okay. You've never seen me be careless before, so get over the shock. Okay. Are you over it? Okay. Now, f of x. So I did f of x minus h. If you did x plus h, then you had x plus h quantity squared. That would have been correct. It's not a form that we usually use, so try to erase it from your memory, but there it is. Again, do f of x plus k. We just write out the formula for f of x and then do plus k. And a f of x equals, well, a is 1/3, so it's 1/3 times 2 to the 1 over x. Okay. And you know, I'm being a little inconsistent with the way I'm doing this, so let me be a little more consistent. Up here, I was putting in the symbols and not the numbers. And on this last one, I put in the number, should have been a f of x is just a times f of x, which is a times x squared. A f of x here is a times 2 to the 1 over x, which is a times 2 to the 1 over x. And I never did f of x minus h. The x gets replaced by x minus h. And the x is a denominator with 1 in the numerator. So the x minus h is going to be the denominator with 1 in the numerator. So make sure you understand that. And if you don't, you might take a look at the videos for the support course. We did a lot of this today. Okay. And I should probably post those links for you. Okay, well, anyhow, there we have it. Now, in this case, h is -2, so that's x minus -2 squared, which is x plus 4 squared. X plus k is x squared plus k, and k is 5. A is 3, so ax squared is 3x squared. In this case, k is -5, 2 to the 1 over x plus k is 2 to the 1 over x plus 5. A is 1/3. So this gives you 1/3 times 2 to the 1 over x. And h is -5, so it's 2 to the 1 over x minus -5. And of course, that needs to be simplified, 2 to the 1 over x plus 5. Now, if you were doing x plus h, you'd have an x minus 5 then. Okay. Make sure you understand these. Okay. And if you don't, email me. I'll send you a link to the support course. I'll send it. Anybody asks for it, I'll send you a link to the support course. I'll send everybody a link. Okay. What's the matter with this thing? Okay. Sometimes you got to talk firmly to it before it'll finally respond. Okay, well, as long as you know it's anomalies, it works pretty well. Okay. Okay. We need some room to do this. -2 will go here and 2 will go here. Okay. Now, first thing we do is in the first quadrant, we make a rectangle. It goes all the way up to y equals 8. And we put a mark here. Okay. Now we cut this thing in half and cut it in half again, just as we did for the squaring of the exponential function or the reciprocal function. Okay. And then we divide it this way. Now we're going to divide it this way more times. Okay, we're going to divide it in half. Divide the lower half in half. And divide the lower half of that in half. So we divide it twice, and then the third time we divide it, we put a mark here. Okay. Then we divide it 3 more times, which is going to make that last division pretty small. So we try to do this honestly. We try to, and there it's cut in half. That half is cut in half. Now this last half, you're probably not going to be able to see it. You understand, if we cut the thing in half a third time, it's going to be down really close to the x-axis, right? And then on this dotted line that corresponds to x equals 1/2, we make an x that's very close to the x-axis because you have to divide this in half 3 times. It's getting really tiny there. We understand that? Because if you do that, you're going to have an antidote to something that people do that distorts the graph of this thing. You have to understand this point to understand how the graph really pretty much almost flattens out, okay, when you get here. Because then you're going to have the red dot. Okay. Now you do the same thing here. If you go down the right side, you do the same construction. At least it's like you flip this one over around here, and you start down here. Cut it in half. Cut it in half. And cut it in half once more and make a mark. Then you got to cut it in half 3 times. 1, 2, 3, before you can make your next mark, which is going to be really close to the x-axis, closer than I actually made it here. Okay. Now, you might not have all that in your head. I'll write out a set of procedures, but you can always look at the video because it's not that long in the video. Doesn't take that long in the video to see this construction. Then we sketch our graph. That was completely flattened out here. I didn't do that totally right. But that's what the graph looks like. Now let's just see. Hang on, let's make these 3. Okay. Make it in a minute. Okay, so if x equals 2, what's x cubed? Show me with your fingers. Yeah, if you think it's 6, you're wrong. You're raising it to the 3rd power. Nobody's had 6. Somebody didn't have fingers up. You might have been thinking 6. So if you did, make sure you understand what's wrong. Means 2 times 2 times 2, right? 2 times 2 is 4, times 2 gives you 8. So that's 2 cubed, which is 8. And I want you to be able to explain why 2 cubed is 8, not just punch it into your calculator and get 8. That's something you have to be able to calculate and justify, okay? Then, well, what are the coordinates at this point? Well, x is 2 and y is 8, right? Oh, that's yes. It's the graph. Okay. Now, this point right here, the second point that I marked as I went back toward the origin. Show me with an appropriate finger what the value of x is at this point. It's 1, right? What's the value of y? It's 1, because this was 8. I divided it in half, that gave me 4, right? So we could even label this as y equals 4. This is y equals 8. Then divide that in half, we get 2. Divide that in half, we get 1. Now, we divided it in half 3 more times, so we'll figure out what that is. But you're telling me this point is 1, 1. Is that okay? Well, if x equals 1, then y equals 1 cubed, which is 1. So if x is 1, y is 1, so the point 1, 1 is okay. That checks. Okay. Think, what's the coordinate of that third point that we made back toward the origin? And let me pause so you can say it. Okay, well, people, a little hesitant to answer this. Here's y equals 1. We cut this y equals 1 rectangle in half. We're going to get y equals 1/2. Cut that in half, we're going to get y equals 1/4. Cut that in half, we get 1/8. So this point is one half, 1/8. You know this is 1/2 because it's the same division that you use for the squaring or the reciprocal function. Okay, so you got 1/2, 1/8. Over here, the coordinates are the same except the x coordinates and the y coordinates are both negative. Like if you square, or if you cube -2, -2 times -2 is 4. Multiply that by -2, you get -8. Okay. Now I'm saying that a little bit fast, and if you've done all your arithmetic with calculators since you were 8 years old, you might have a little trouble understanding. Go to the video, listen to me say it 2 or 3 times, write it down, because I'm not going to take the time to write it down. You should know. And I think you do. But if not, you know, take another look. Think about why that would be -8. If you cube -2, you get -8. If you cube -1, you get -1. Now let's check the 1/8, okay? Well, if you know the rules for fractions, you know you do 1/2 times 1/2, which gives you 1/4, times 1/2, you're going to get 1/8. You should know that just by subdivisions, and you should know it by the rules for arithmetic. Okay, and if you do, then you already understand these functions better than most pre-calculus students will at the end of the course. Okay, nationwide. Because most students in pre-calculus end up doing it all in the calculator and never do understand what it was they were doing. They understand a lot of things. They still don't have a deep understanding of these functions. Okay, and we want to start with a deep understanding of these functions. I say most pre-calculus students stationary. Okay. There's some places where they can really do the pre-calculus course totally thoroughly in students who've been doing arithmetic with something other than a calculator and understand all the relationships quite well. Okay. I want you all to have a good portion of that understanding. You can understand and get it kind of the elite scores. Okay. Well, that's your cubing function. The reciprocal square function. We're back to our favorite 4x4 cube. Okay. And we divide it vertically the same way we did squaring function. And the reciprocal square is y equals 1 over x squared. Very easy to calculate, except when you got a fraction in the denominator. So how do we construct it? Well, we subdivide it here. We subdivide it here. We subdivide it here, and we subdivide it here. The lowest point is y equals 1/4, and you know I lied. Okay. I take it back. I knew I hadn't lied because I never lied. Okay. Thought I'd done something really stupid, but for once I didn't. Okay. So yeah, understand. This is lined off the same as the exponential function, in other words, identical. And you're used to that, you're familiar with it, so you should understand it pretty well. Now, what points do we do? Uh-oh, I did lie. No, I didn't, I never lied. Okay. All right. We start with this point right here, which is the same point we start with for the exponential function. Down there on the y was 1/4 line. Okay. Then we go over 1 and up 2. And make a mark. And then we go over 1 and up 2. Now remember, and I hope you remember, for the squaring function, we'd start up here and we go over 1 and down 2. Right? That's the rule for the squaring function. The rule for the reciprocal squaring function is go over 1 and up 2. So it's very similar to the squaring function, except we start here and go over 1 and up to, okay? And then we stop here, just like for the reciprocal function, we don't connect this point to any point that we get on this side. Because if x equals 0, this thing's undefined, so you can't go through the y-axis. Hopefully everybody understands that. It might be a little fuzzy. It's not a trivial concept, and you're not used to thinking about things that way, although I hope you're getting used to it. Okay. So over here, we do the same thing. Here, here, and here. It's just a reflection. If you want to think, we start here, then we go over 1 and up 2, and then over 1 and up 2. Okay? It's a little different than the squaring function, which kind of continues in a different way. But we're moving toward the y-axis in both cases. We're moving toward the middle of our 4x4 square. So in some ways, this graph is somewhat similar to the reciprocal function. In some ways, it's different, like it's symmetric, where the reciprocal function is symmetric in a different way. What's up here is reflected down here. Okay. Now you can do the arithmetic and figure all this out, and I'll probably give you a short written assignment where I just ask you to do that arithmetic. Okay. Not going to add anything, any significant written assignments. I did send an email out that says, you've pretty much had your last long written assignment, okay? Okay, well, I'll give you written assignments, but they're not going to be extensive because we're going to be relying on open math to do some of the basics, and then we try to fit it in to the whole scheme that we've developed in 3 weeks, okay? So, now just a comment on the homework. I think most people started too late in the homework. Maybe it's because, you know, you work 16 hours a day over the weekend and couldn't start it till Monday night because I didn't send it out till Friday. Okay, I couldn't get it done any quicker. You know, I had to make sure that things were right, that they made sense, that I was asking exactly what I wanted to ask, or at least that I was pretty close to asking what really needed to be asked at that time. And it took me a day to do that. You know, Thursday's kind of a full day, so it had to spill over here to Friday. Be better if I'd get those assignments out a day earlier, because the sooner you're able to start them, the better you're going to remember what we did in class. Now, see, the way the class runs is we have a class today, we have a class day after tomorrow. Then it's 5 days till the next class. If you wait 4 days to start your homework, you lose track of whatever we did in class. Okay? You want to at least look at it and get your brain working on it as quickly as possible. Okay? And in the case of the open math assignments, this means you probably ought to read the text right away. Because the text will tell you what I've told you, but they'll be able to do it in more detail with more words. Now, sometimes it won't be exactly the way I told you, but that's an advantage, because if you understand it 2 different ways, you understand it much better. Especially the 2 ways are pretty easy to, it's pretty easy to see how they relate to each other, okay? So, you know, in class, I can give you a fairly brief explanation focused on the main ideas, and I can watch you work on it. So that I'm pretty confident that when you walk out of class, you're ready to read the text and get the homework. Now, if you pretty much know this stuff, you probably try to go directly to the homework and use the videos that go with the first few problems, because they'll tell you a lot too. Tell you basically the same thing the text is telling you. At some point, you should still read the text, okay? Because there'll be things you'll understand in reading the text you didn't understand when you did the homework. And if you're stuck on the homework, by all means, if the videos aren't doing it for you, look at the text, look at what we did in class, access whatever it is you have access to that helps you understand what to do. And you know, between Tuesday and Thursday, you probably don't have a whole lot of time to take a quick look at it today and then really dive into it tomorrow. Or dive into it a little bit today and then wrap it up tomorrow. It's better if you spread it out. If there's something you don't understand today, sleep on it. There's a very good chance you're going to understand it tomorrow. Okay? Kind of take that as words of wisdom. Took me a while to learn that as an undergraduate. Okay. Matter of fact, in my sophomore year, I had to lay out the first semester because I had to have a spinal fusion. Congenital defect, fairly common, but it okayed me to go play football again the next year. Everybody but the coach thought I was terrible and didn't want to be in the team, but that's a different story. Actually, I had some skills, just didn't have a good combination of skills. I could throw the ball really well, and I could catch the ball really well, but that's not a good combination of skills. I can't do both at the same time. Oh, well, that relates to something I might or might not say in a minute that's relevant. The point is, I knew I had a linear algebra course coming up. Linear algebra is, you combine calculus with algebra with geometry, and it's a tough course, okay? It's algebra with not steroids. In three-dimensional space or in 40-dimensional space. Okay, it's kind of neat. And I said, okay, I'm going to be in the hospital for a couple of weeks because back those days they didn't release you very soon because they did them differently. It worked. I mean, it's still solid as a rock 60 some years later. Okay, 50 some, close to 60. So I said, I'll take my linear algebra book and read it. Okay. So, I came out of surgery, wasn't in a particular pain, but I'd lay flat on my back for a week. I had a trapezoid so I could lift myself up and down. But I had my book. Felt okay after the first day and didn't feel that bad the first day. So, there I am in the hospital with nothing to do. Okay. So I've got my linear algebra book. I'm trying to read. I got about 6 pages into it and couldn't understand a thing. Okay. Well, the next fall, and I went back in the spring, I did real well in a couple of courses, but went back in the fall, took the linear algebra course, and all of a sudden it was clear to me. The only thing that had happened is my brain had tried to process when I wasn't really trying to process it. It tried to process that first 6 pages, which it didn't understand, and all of a sudden it understood that and everything else in the course. Okay. I mean, I had to work at it and I had to keep reading. I couldn't figure out the whole course based on the first 6 pages. The point of that is that you let your unconscious mind work on something, not over a period of a year, because in this course you don't have that long, unless you end up taking the course again next year, next spring or whatever. I hope you don't have to do that. Keep working hard, and I don't think you will. Okay. The point is, by analogy, if you look at it today and then wrap it up tomorrow, your unconscious is going to sort out some stuff, and it's going to be much easier and take you less time to finish the assignment with a better score, okay, and more understanding. So you come in here the next day and you can pass a quiz on it, okay? And over the weekend, if you've got 3 assignments to do, it's very likely that each of those assignments is going to build in some small way on the one before it. I'd start taking a look at all 3 of them, just a quick scan of the text or whatever. Just you recognize anything, but okay, maybe your subconscious will sort it out a little bit. But don't start on the first assignment the night before 3 of them are due. You'll be up all night. You're going to take a lot longer. You're going to lose sleep, or you're going to lose points, and you're not going to do well on the quiz. You're not going to learn it as well. Does that make sense? Try to do that. Try to spread the learning process out. Okay. I understand life is such that it's not always possible to do that, but make every effort to do some of it, even a little bit, is going to help. Now, that said, I don't think you're going to have any problem with the first chapter, which is what we're going to spend the next week covering. Okay. I don't think you're going to have much problem with the second chapter, which is on linear functions. Y equals mx plus b. Y2 minus y1 over x2 minus x1 is a slope, or the slope is rise over 9, and that stuff. Okay. Third chapter starts with quadratic functions, and you already know most of it. So we're going to move through that stuff fairly quickly so that later on when we get to stuff that you don't know most of, we got a little more time for it. Okay, that's a strategy. All right, I think from what we've done, you're going to be in pretty good shape to move through this stuff. Like the first two chapters and the first part of the third chapter, and very successful, I think. All right. Okay, I'm going to show you how to use the table, which is squaring function. There's the table. And again, you should be able to figure out this table just by constructing the graph and dividing up fours and ones and stuff like that. Okay. Okay, I'm going to call this the inverse relation. And all I do to get the inverse relation, it's not an inverse function. It's not going to be a function. We're going to make it into a function, and that's easy. Okay. The inverse relation here, you put the y column under x, and you put the x column under y. Okay. Then sketch a graph. Actually, let me make this more accurate. Be a little far here. Okay, so you sketch the graph, the squaring function. I'm not going to go through details of the construction, but you go through the construction and you get these 7 points, including the red dot at the origin. Okay. Now the inverse function. Well, let's see, here's x equals 2. It goes all the way up to x equals 4. So you got to leave yourself a little room out here. X equals 4 and y equals -2. Okay. Well, okay. Here's x equals 4, and here is y equals -2. So you've got this point, and let's use purple for this graph. Okay, then you have 1, -1. Well, here's 2, so here's 1. And here's -1, so here's 1, -1. 1/4, -1/2. Well, 1/4, you got to cut this in half and cut this in half. So you're going to get 1/4, -1/2 here. And then you're going to get 1/4, 1/2. Now that's going to be, let's see, here's 1/2. That's going to be about here. And then 1, 1, that's going to be the same place it was for this function. 1, 1 would be a common point for the two functions, just like 0, 0 is for the two relations. And then 4, 2. And what you end up with is a parabola on its side. Okay. Now, this isn't a function. If I ask you what's the value of the inverse relation, if x equals 2, they're going to tell me, well, some of you will tell me, sorry, we don't have it for 2, for x equals 4, okay? what's the value of this relation for x equals 4? Well, the first number you see is if x is 4, y is -2. Yeah, plus or minus. Down here, though, you've got 4, and you're going to tell me it's 2. You can't give me 2 answers. So what we're going to do is we're going to cross out this modular function. Okay? So you only have one answer. And if we cross out these values, that means that we cross out this whole part of the function. And now we're just left with this. Now, since we crossed that out, we're kind of removing the first 3 lines of this. So I'm going to say the numbers here are not needed for the inverse function. These are needed. These are the numbers that we would then invert to get the inverse function. So this is, and if we do that, the green thing is the right branch of the squared function. You have a branch that goes this way and a branch that goes this way. Okay. If we don't use that's the branch that corresponds to the numbers that we do use here to get these numbers. This function the basic toolkit square root function. Now, check and see if it works. If x equals 4, what's the square root of x? Show me with your fingers. The square root of 4. 2. Because if y is the square root of x, if s is 4, y is the square root of 4, which is 2. Okay? Okay? I've got another point here. That's for x equals 1, right? What's the square root of 1? It's 1. Okay? And you got the point 1, 1 on the square root graph. If x is 1, y is 1, so you got the point 1, 1. You just constructed it. Okay, if x equals 1/4, what's the square root of 1/4? What would you multiply by itself to get 1/4? Well, 1/2 times 1/2 is 1/4. Okay? And 0 squared is 0, so there's your graph. Okay? So that's a construction of the square root function. And I mentioned it because square root function is used quite a bit in the first section of chapter 1. Okay, well, we got 21 minutes now, so I give you a heads up on chapter 1. And what I'm going to do, I'm not going to have time to talk much about the homework, but I'm going to write some stuff out for you based on what I've seen. Okay, then we'll take a look at it again next time, see what you've been able to do. Then I'll give you the weekend to finish up, along with some of these assignments. And that should give you good preparation for the test next week. Okay. Now, Okay, what value of x make f of x 0? Can you show me with your fingers? Can you give me one value? Any one of them. If x is 0, it isn't 0. Okay, so I see a lot of zeros every time I ask this. If x is 0, this is -3, this is 5 squared, and this is -2. If you multiply -3 by 5 squared by -2, you're going to get 150. Okay? Check me on that. I did that quick. Okay? So that doesn't work. If x is 0, none of these is 0. And if you multiply 3 things that aren't 0, you don't get 0. Okay? Okay, so I see one vote. Somebody else, give me some numbers. Okay, I'm seeing 2 and I'm seeing 3, and those are both right. Okay, so let's look at it. If x equals 3, (3 minus 3 times 3 plus 5 squared times 3 plus 5 squared times 3 minus 2. If you evaluate this, you get 0 times, well, 64 if you square it. What's 0 times 64 times 1? 0, isn't it? Okay. So this makes f of x 0. Okay. Another vote was for x equals 2. Well, if you plug in for x equals 2, you're going to get 2 minus 2 here. This is multiplied by this is multiplied by this. You multiply by 0 once, you're done. It's 0, right? Okay, yeah. Can you show me another number that would make this 0? Yeah, -5. X is -5. Okay. Because again, all you got to do is have one of these factors equal to 0. Okay. Now it turns out that this tells me something about the graph of this function. Now we're going to learn a lot about the graph of this function here in 2-3 weeks, okay? But we know that y equals f of x is 0 if x is 3, so we know that the graph goes through the point 3, 0. X equals 3, y equals 0, right? And it goes through the point -5, 0. And it goes through the point 2, 0. If x is any one of those numbers, y is 0, so the graph has to go through those points on the x-axis. It's very straightforward. Now we'll write that out. You don't necessarily, if you see it, that's great. If you don't see it, just try to believe it. And we'll see it later. I'm giving you a little preview. Another thing is, near the point where x equals -5, this graph behaves like a squaring function. It behaves like a multiple of the squaring function, shifted 5 units in the negative x direction. Okay, so you shift that squaring function over here and then stretch it a whole lot, because let's say you have to stretch it by a factor of 56. So you'd have to have a 2 by 224 rectangle to draw your squaring function, okay? But it would behave like that squaring function. That's a prelude, and that's one reason we want to really understand the squaring function and the transformations, so we understand the graph of this function. Now, if we had a few more minutes, I'd draw you a picture, but we don't. So if you really want that picture, ask me next time. I have time on God. All right. This is called the zero factor theorem. You see it in the first section of the chapter. Okay, now we want to talk about how you solve x. Square root of 3x minus 7 equals 8. Okay, so to solve this for x, and a lot of people think they can solve it. I believe you. Okay, a lot of people didn't raise their hands and say, could you solve it? I think a lot of the people who didn't raise their hands could if they thought about it. But some people, you know, they may be a little fuzzy in this. What do we do to both sides? Well, x is trapped under that square root. So we square both sides. And this leads to what do you get when you square the square root of 3x minus 7? Now, in algebra class, I'd wait and walk around, see what you do, but you should know. And if you don't, it should be familiar after I do it, okay? And if it's not, let me know. If you square the square root of something, you get that something. There's no plus or minus involved like there is when you solve an equation. As a square function in it. Forget what I just said, it was badly phrased sentence. But anyhow, you get 3x minus 7 equals 64. And you know what to do, add 7, then divide both sides by 3, and 71 over 3. Question mark, because I did that instantly in my head, and I never touched it. All right, straightforward. Okay. That's how you solve the square root of something equals something else. You square both sides. How many think you're going to remember to do that? I think you will. If you make yourself a note to remember. Okay. There's something there that I'd like to do that I won't be able to. Okay. Now I want to talk a little bit about how you can extend these toolkit functions. So here's the toolkit square function. In its 4x4 box. Okay. There's a rule for extending this function. And that is that every time you move twice as far from the y-axis, you get 4 times as far from the x-axis. You can check that out in the basic toolkit squaring function. We've actually done that. I talked about that in class one time. Whether you picked it up or remember it, if you haven't had to use it, maybe you don't remember. Okay. So if you want a bigger graph, I mean, if this is -2 and this is 2, and you want a bigger graph of y equals x squared because it's not confined to the interval from -2 to 2. The basic toolkit squaring function is, but you can build on that. If you move twice as far from the y-axis, that would move you out to here, right? Okay. So twice as far from the y-axis puts you on this line. So you go twice as far. You got to go 4 times as far from the x-axis. 1, 2, 3, 4 times as far. Shouldn't have labeled that. Where I did, you got to move up pretty far. And see, we're already going to be off the top of the graph. Okay, so we go 4 times as far. 1, 2, 3. 1, 2, 3, 4. So it takes us up to about here. So we have this far, we go this far again, we go this far, 3rd time, and we go this far a 4th time, actually puts us about here. Twice as far from the y-axis, 4 times as far from the x-axis. So we have this point, and now we can extend the graph like so. Gets very steep. If we go twice this far, we'd be out here. Twice as far as this puts us out here someplace, and 4 times as far as this, well, that's about 9 inches. Okay, 4 times as far as 36 inches. We got to go up 3 feet. Okay, I stopped jumping years ago when I developed heel spurs, so I'm not going to do that. And also, I have to restrain myself because I'm afraid I'd destroy the ceiling. Okay, we do the same thing on this side. We go twice as far from the x-axis. So it put us on this line. We go 4 times as far. And of course, that keeps the graph symmetric. And there's this shape, a little more extensive curve. It was really badly drawn, but if you draw it carefully, you can do it. Does that make sense? It should, because you're used to cutting things in half. It's not hard to think of doubling things or fourpling things. Okay. Yeah. To make something 4 times as big. I asked in class many years ago, probably 30-some years ago, maybe 40, I don't know, 70-some. But anyhow, had a student, good student, and he had an interesting personality. And I said, what happens if you make something 4 times as big? What do you call that? Looking for the word quadrupling. And he knew, but he couldn't get it. Fourpling. Sounds vaguely obscene, so we like it. Okay, so anyhow, so if we double this way, we fourple this way, right? Make sense? I don't know what you're thinking. Okay, now, so yeah, interesting looks on your faces. And I don't know when the camera came out of focus. And picture. Okay, now there are other rules. The other function. But this side of the picture, maybe it'll focus. Yeah, there it goes. Okay. If you do the reciprocal square function, if you go twice as far, you go 1/4 you go 4 times as close to the x-axis. Okay, it's kind of like a reciprocal one. Okay. If you have the x cubed function, if you go twice as far this way, you go 8 times as far this way. Okay. So I'm going to write down those rules for you, kind of in a little table and send it to you. And expect you to play around with them just a little bit. See if they make sense to you, maybe solve a couple of problems, just 1 or 2. If you know how to do that. So it's important to see how these extend. The other one, and this is actually even more important than these, but the squaring function is quite important. But the exponential function is incomparable for its importance in mathematics and in applications. So we take an exponential function. And points are here, 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 and here, and I didn't really need so many points. So there's a picture, right? Okay. You move one unit to right, you get twice the y value. Okay, I mean, that happens, doesn't it? What's the y value here? Show me the finger. 4. This is 4. This is 2, this is 1, this is 1/2, this is 1/4. Make sure you're real familiar with these. So this is 1. Okay. Now, how far do I go to the right if I move one unit to the right? Well, it's going to be here, isn't it? And the y value is, what's the y value here? 2. It doubles. What happens if I move one unit to the right here? The y value goes from 2 to 4. It doubles again. Every time you move one unit to the right, the y value doubles. And you could estimate a y value if you have a curve. But we can first follow the rule. If we move one more unit to the right, not twice as far, just one unit to the right, you got here. You got to go twice. You got to go all the way up here. The graph extends like this. That's about a foot. If you do this 14 more times, you'll be more than a mile high. Okay? Yeah, about a mile and a half, actually, a little more than a mile and a half. Okay. If we go to the left, of course, that means every time we move one to the left, go half as high. This ain't very high. Half that high is even less high. Okay, so these points here, if we move one unit to the left, one unit at a time, are very quickly going to be indistinguishable from points on the x-axis. They won't actually be on the x-axis, but you won't be able to draw them, so they don't look like they are on the x-axis. Okay, does that make sense? So this thing takes off like crazy, much faster than this one does. Because to double this one, you got to go twice as far. To double this one, you only got to go one unit to the right. Okay, those are important properties, and we'll start connecting the algebra to some of these properties over the next week or two. The algebra is actually pretty simple. Okay.